So today we're going to take a look at rational expressions. And the thing to remember is that rational expressions refer to fractions. So it just means the rules of fractions. And just like fractions, they can be simplified sometimes. And the fraction rules are going to apply, including BEDMAS. Now there are 4 levels that we could be covering. We're just going to be doing the first 2, simplifying and doing multiplication and divisions. So we'll start off with simplifying rational expressions. Let's get the legal stuff out of the way here. A rational expression is basically P over Q, where P and Q are polynomials, and the restriction is that the bottom of the fraction, the Q expression, is not allowed to equal 0. So here are a few examples. These are, like I said, multiplications on the top or operations on the top with variables, and we're going to figure out how to tame these by factoring and canceling. So simplifying a rational expression means writing it in lowest or simplest form, using the fundamental principle of rational expressions. So some more legal jargon here. If P, Q, and R are all polynomials and Q and R are not equal to 0, then we're allowed to reduce the fraction by dividing top and bottom by R. The main criteria, again, is that the denominator values are not allowed to equal 0. Some things to watch out for. First of all, you're going to completely factor the numerator and denominator. You're going to apply that fundamental principle of rational expressions to divide, cancel out the common factors in the top and the bottom. Watch out. You can only cancel common factors. In other words, the safe way of doing it is just say, is it in a bracket? And do the brackets match? They have to be parts of a multiplication. So here's an expression, and let's watch out what you're not allowed to do. So the temptation is, oh, why don't I just cancel out the x's and the 35 and 5? The reason you're not allowed to do this is because there's additions that are holding those pieces together. We can only cancel away factors, the pieces in a multiplication. So by factoring this thing, we now have 2 brackets that are identical. They are 2 factors that we can divide out of the top and the bottom, leaving us with 7 over x. Now, the restriction that x is not allowed to equal 0 is something we pursue further in secondary 4. So here we go, our old friends, simple trinomials. So we take them and we factor. If you're doing it properly, 90% of the time, you're going to see common brackets. You're just going to cancel them out. You write those final brackets. You can leave the brackets there if you want, but whatever you do, don't think you can cancel those x's or the minus signs, right? That's your final answer. Here's another one, which, watch out, there's a special way of handling it when there's a reversed subtraction. We've seen this before. Basically, they are opposites of each other. So if I factor a negative 1 out of the top, I can rewrite it as a positive y minus 7 on the top. And now those 2 binomials are equal. Remember, the bottom of the fraction is just a 1, so I don't even have to write it. Negative 1 is my final answer. Let's take a look at the next one. Another way of doing it. And this is the way I'm probably going to have most of you do these questions, because it's a shortcut as long as you recognize that negative means opposite. So in other words, I can cancel those opposite brackets, and I'm just going to get a negative 1. So I call this chop chop negative on top. We'll see that in class. And your answer is negative 1. So we're kind of skipping that step where we show the division out by negative 1. Multiplying and dividing. So here's where we're going to get into the larger examples with more terms. And the rule, here's the legal jargon again, P, Q, R, and S are polynomials. The Q and the S are not allowed to be 0 because they're going to be in the bottom of the fractions. And basically, you can multiply the tops together and you can multiply the bottoms together. Top times top, bottom times bottom. Now, in this case, nothing cancels, but that's just showing you the layout. So here's how we do it. I'm going to give you expressions. You're going to factor the top and the bottom. You're going to simplify by applying the fundamental principle. You're going to cancel the common factors and then just sort of group all the numerators and denominators in their locations. And ironically, you don't even end up multiplying in most of these examples. So here's an example, simplify the product. And cancellation fest here, okay? You can just sort of rip them up into their group of factors and just cancel all that match. Remember, one on top for each one on the bottom. So I got some leftover 2's there that would be in the denominator. Now, I'm going to expect you guys to speed this up a little bit by just canceling along the way without rewriting it. For example, the 6 and the 10 and the x's. So we can do it this way. Oh, 6 and the 12, 5 and the 10. Notice I'm putting those numbers in place, and I got 3 x's on the top and 3 x's on the bottom, and at the end of it all, it's 1/4. Now, the only caution I have for you at this point is if you're not neat and organized, you may end up leaving a couple of details behind before you go to write your final answer. Next example. This one, you're tempted to do some canceling right away. It's kind of safe to put everything in brackets first, but I'm going to rewrite these pieces as multiplications, and then only when they match exactly. So the m plus n and the m minus n will not cancel. In fact, you can't do anything more at the end of this. It just stays like that. Dividing, and here's the setup again. P, Q, R, and S are all polynomials, and you can take the second fraction, R over S, and multiply it as the reciprocal, right? You flip and multiply, and then put the pieces together. But like I said, we're probably not even going to put those pieces together because we're going to cancel them away if we can. So let's check this out. You change the division into a multiplication. You take the reciprocal of the divisor and treat it as a multiplication problem. You can only cancel when it's multiplication. So even though I might be tempted to cancel at the start here, don't. Rewrite it with the second fraction flipped. Then you factor. Everyone see all the little pieces there? Now, I didn't really have to break the 25 up like that, but I wanted to show it this way. And the factors left over, x plus 3, that binomial. That's your final answer.